7.2. If you look over here, on geometry. Second day of March, our first school day of March, guys. We're getting close to spring break. We're almost there. Spring break is 2 weeks from now. It does. It starts on a Friday. We have 6 days off in a row. 3 full days off in a row. Holy buckets, is that nice, okay? So, pretty neat. Today, SWBA, students will be able to identify and use properties of special right triangle. Section 7.2, okay? So we're going to start off with an investigation.
Oh, no.
Not police work, we're going to do an investigation.
What do you call an alligator in the vest?
Wait, did you calibrate your thing because it's super bad?
No, it's okay.
It's so off.
Okay.
Fix it.
Find the length and hypotenuse of each isosceles right triangle in simplest radical form. So, we're told this is an isosceles right triangle. What's isosceles mean?
It's
sides
right.
equal.
2 sides are here equal in measure, and then we know it's a right triangle, so it has a right angle in it, right? And so we can use the Pythagorean theorem if we know 2 of the sides.
No.
Do we know 2 of the sides on the first triangle?
No.
Wait, yeah.
Oh, we do.
Because if this is 3, what else do we know?
3.
The bottom is 3 because they're congruent to isosceles. Jeepers, what in the world? Okay, now could we do the Pythagorean theorem here? Okay, let's do the Pythagorean theorem here. Can somebody help me set this one up?
What?
Can somebody help me set this one up? Solve for this missing side A. Yes.
3 squared plus 3 squared equals a squared.
Yeah, 3 squared plus 3 squared equals a squared. Okay? Jeepers. Creepers.
Where'd you get those?
Exactly. Yep, equals a squared. Typically, it's a squared plus b squared equals c squared, but it's always the 2 legs squared added together equals the hypotenuse squared. So here, a happens to be the hypotenuse. Yep. So what is 3 squared? 9. Did 3 squared change in the last second? No, it's still 9. No? Okay. 9 plus 9 equals a squared. So what's a squared equal to?
18.
18. Can we simplify this after we square root? You
Yeah.
betcha.
Sadly.
Square root of what times square root of what?
9 and 2.
9
Square root of 9 times the square root of 2 equals a. So what is the square root of 9?
3.
3. So we have 3 square root of 2 is our a.
Cool.
I want you guys to go ahead and do 2, 3, 4, 5, and 6.
So the rest of them?
Yep. Because I mean.
I mean, I'm Kevin.
I'm doing a check too.
Taylor. Taylor's a germaphobe.
I don't know how to tell time.
10:14, 10:15. Yeah, I said 10. But I don't know if it's gonna change. I told you to get right credit.
Scoliosis, you're a mess today.
Anyway.
You guys hear her too? You should let her back in for a little while.
Alyssa, just to prove I know your name, what was our hypotenuse on number 2? 4 times square root of 2. Okay. So if we go through the leg on the first one, we fill in this chart. The leg on number 1 is 3. The hypotenuse is 3 root 2. On the second triangle, number 2, the leg was 4. The hypotenuse is 4 root 2. On 3,
No, don't let her in.
There she is.
on 3, our leg
Hold on.
was
Wait,
5. Kayla, what did you get for your hypotenuse? Yeah, for 3. Yeah, 5 times square root of 2. Owen, on number 4, what is the length of the leg? Okay, it is 6. Now, what was the length of your hypotenuse that you got?
6.
6 times square root of 2. Okay. Simone, on number 7, what was the length of your leg? You say on number 7 or number 5?
He said number 7.
Yeah, oof.
It's 7.
Yeah, and what's our hypotenuse?
7
7 square root of 2. Okay, and last but not least, on number 6, Kevin, what did you get for our leg?
12.
And our hypotenuse is
12 is square root
12 square root of 2. Are we noticing a pattern here, guys?
Mm-hmm.
What's our pattern?
2. It's the number
Same.
to the square root of 2. Is
Yeah. Go from leg to hypotenuse. What mathematically would we do?
Square root of
What was square root of 2? Add it
2. Times it.
times by the square root of 2, and you get your hypotenuse. Every time. I don't care what kind of isosceles right triangle you have, this would be the case. Okay? I don't care what kind of isosceles right triangle you have, but this would always be the case here. Now, what are our angles going to be in this triangle? Does anybody know?
45.
45? Yeah, because these two angles have to be what, guys? Congruent for it to be isosceles. And so if this one's 90, these also have to add up to 90. You add it to 180. These are both 45 degrees. So if we look right below this, we have this theorem. And a 45, 45, 90 triangle, that's what we call it because of the angle measures. 45, 45, 90. Okay, so it's a special type of right triangle. The hypotenuse, the longest side opposite the right angle, is always going to be square root 2 times as long as each leg. The legs are the same length, and the hypotenuse will always be square root 2 times as long. So if you take your leg length and you multiply by the square root of 2, you will always get the hypotenuse. Now I want you guys to draw this little map with me, so to speak. So on this 45, 45, 90 triangle, if I have this leg and it's x, what would my other leg be? X. Okay. Now what would my hypotenuse be?
Y.
Okay. Or how can I say it in terms of x?
X squared.
X times square root of 2. Because whatever this is, we're just going to multiply by the square root of 2. So I also want you to draw this. How do we go from the leg to the hypotenuse? Mathematically? How do we go from the leg length to the hypotenuse length? Not double it.
Times.
Multiply by the square root of 2. Now, how do we think we might go back? If we started with the hypotenuse and we went back to the leg.
Put it to the power of 2.
The power of 2. What? I heard it? Divide. What's the opposite of multiplication? Division. And so divide by the same measure. By the same number. So if we multiply by square root 2 to get there, we can divide by square root 2 to get back. It is crazy stuff, man. So this is a pattern we'll always see. And so you can save yourself time to where if you see a 45, 45, 90 triangle, you don't have to do the Pythagorean theorem. You don't have to do 12 squared plus 12 squared is 144, plus 144, that's 288, and go through and simplify that back down to the square root of 144 square root of 2, 12 square root of 2. You can just say, oh, 12, 12, our third side, our hypotenuse is going to be 12 square root of 2. Yeah.
So how on a calculator would you do divided by square root 2? Would you just say like the number and then hit the square root button and then put 2?
Sure. Otherwise, we are going to do this in simplest radical form, though.
Oh,
Yeah, we'll see a couple examples here. Great question. So I want everyone to make sure they have this map thing, though, this little map with the arrows and everything, though. It's pretty important to me that you have that because later on when we're reviewing, when we're getting ready for our test, when we're doing homework for this section, I'm going to keep referring you back to this map whenever you ask me questions. So I was going to say, hey, let's look at our map and let's go back to that. Let's make sure we know what we're doing. Yeah. I think this is a helpful way for you guys to learn it. Okay. So, example, solve for x without using the Pythagorean theorem. So we're not going to use the Pythagorean theorem, and we're going to solve for x. So for letter A, I want you guys to go ahead and try that. Try solving for x without using the Pythagorean theorem. Go ahead and write it down. Want to think about it? Write it down. If you need help, look back up on the map we just drew. Did it disappoint you that it didn't?
Nah.
Thanks, Savannah.
I said beautiful.
Good. I'm used to that too.
I used to that too, I'm sure.
Why is your hand cold?
It's always cool.
Are you in?
I like so. Okay. Can everybody tell me what they got?
18 square root of 2.
Yeah, 18 square root of 2, 18 times square root of 2, 18 root 2. Because in a 45, 45, right, 90 triangle, we know it's 45, 45, 90 because it's an isosceles, right? So these had to be 45 degrees each. Leg times square root of 2. Okay. How would we go on letter B? What would we do here? What are we given to start with? We're given the hypotenuse, and what are we trying to find now? Leg. So how do we go from hypotenuse to leg in a 45, 45, 90 triangle? Divided by root 2.
You can't have a radical.
Ah, but we can't have radical on the bottom. We don't like it there.
Yeah.
So how do we get rid of that radical on the bottom? Melissa? Multiply that by the square root of 2 over the square root of 2, because the square root of 2 over square root of 2 is secretly 1. We just make it look different. Because if we multiply by 1, it doesn't actually change the value. We keep it the same number. Now, what is the square root of 2 times the square root of 2 on the bottom?
2.
Normal 2. Square root of 4 is just a normal 2. 18 times square root of 2 is just 18 times the square root of 2. Do we have a radical on our bottom anymore?
No, but you can simplify.
No, but we can simplify. What do we actually end up getting? 9 square root of 2. Did Did we have to use a Pythagorean theorem here? Nope. Otherwise that'd have been messy.
Wait, so how come like we didn't take square root of 2 divided by square root of 2 as well?
Over here?
Yeah.
We just use this as a tool to help us get it to look like this.
Okay.
So this is secretly number 1.
But for 18 times square root of 2 over 2,
Yep.
how come you're not taking square root of 2 divided by 2 as well?
So these are multiplying together. So just like after you factor, you can just go through and simplify things and we multiply together, same idea. So this 18 and square root of 2, you can just simplify this 2 and 18. Okay? If there is a plus or minus sign in between the two, we need to do it, but because there's not, we're good. That make more sense? Okay, good question. Okay. Any other questions on this one? Liddy! Okay. Anybody curious, by the way? It is 3 months and 25 days from today. Yeah, we're in the 3-month category, but I don't have to say 4 months anymore. You say I'm the only one in here that's interested in that?
I said you're the only one that's counting.
Oh, no, that's not true.
She's counting.
Yes.
But other than that, nobody else.
You're probably actually one of my roommates is because he's getting married in a month and 2 less days than I am, so we know each other's count. So he's getting married in 2 months and 23 days.
Okay.
The tall one. Nate.
Why do you know his roommates?
Because you play soccer. Those are open gym. I can tell that they're your friends.
No, they're just random people are just chilling, you know.
Not exactly like me.
I would hope not.
If there was another Mr. Costle, I don't know what I would do with my life.
There's like 2 others.
Well, actually, there are 2 others. My dad and my brother. Okay. Thanks for like
Don't
the
laugh at
sad,
it. It's not
depressing
funny.
laugh. That's the perfect one there. Okay. Hey, we have this equilateral triangle. If you flip the page, equilateral triangle. So I'm telling you it's equilateral, and I'm telling you that CD is an altitude. Let me flash that for a minute. Yes. So what are the measures of angle A and B if this is equilateral triangle?
45. Wait, 60.
60. It's a whole big triangle. A, B, C is equilateral. And we know angles A and B are both 60 degrees, right?
Yeah.
And so is the big angle C. So these are all 60 degrees. Okay? If CD is an altitude, what's that mean? It makes a right angle. It's perpendicular to the side. Very good, very good. Okay? Altitude, think height, so it measures the height. If you perpendicular to the ground to measure a height, we can't be slanted. Okay? So it makes a right angle. So what's the measure of angle ADC and BDC?
90.
90 degrees. Okay. What are the measures of angle ACD and angle BCD then? 30 degrees, right? We can do some math here to figure that out. Say, okay, well, if this is 60, this is 90, 150, so it has to be 30. Okay? Do we have enough information to prove these triangles congruent?
Yes, we do.
Yes.
Okay. Yeah. What? By what method? Angle similarity. Angle side angle. What side do we know? Yeah, CD, DC. We know that side. So another side. So okay, we know these triangles are congruent. So yes. By angle side angle. So by that logic, does segment AD have to be congruent to segment DB?
Yes.
Okay, so yeah. Okay. These have to be congruent then, right? We worked that out where, oh, they have to be congruent. Now, we know this whole thing is an equilateral triangle. We were told that, right? So if we know this length is, let's say, x, what's this length over here? X, okay? And now A to B would all be what as well? X, okay? So what would that make? Actually, let's go through, let's change the name to 2x, 2x, and 2x. Because we can call it anything, so let's call it 2x. What would I call A to D? X. I just call A to D normalized because it'd be half of this, right? And what would I call D to be? X as well. So we create what we call a 30, 60, 90 triangle. So we create what we call a 30, 60, 90 triangle over here, where this is 30, this is 60, and this is 90. This will be another one of our special right triangles. Now in this, we have two legs, the one across from 30 degrees and the one across from 60 degrees. Which one has to be shorter every time? The one across from 30, because the smaller the angle, the smaller the opposite side. You guys remember that from a couple chapters ago? Last chapter. Okay? Remember the phone trick, the flashlight trick? Okay? So this is always going to be our shorter of the two legs. Okay, so we'll call this short leg. Now our short leg is what compared to the hypotenuse of this triangle?
Cooler half.
Half. It's cooler. Okay, maybe. Okay, it's half of it. It's half of it right now. So that means the hypotenuse is what compared to the short leg?
Double.
Double. Okay. Half and double. Okay. So that's our first thing we're gonna write here. In a 30, 60, 90 triangle, in a 30, 60, 90 triangle,
Purple.
in a 30, 60, 90 triangle, the hypotenuse is how much as long as the short leg? Twice as long. Is twice as long as the what we'll call short leg. Because we have two legs and one has to be shorter than the other. We'll call it the short leg. So if I were to go over here, and I'm once again on across to my 30 is my short leg. Across from 30 is my short leg. Okay, I'm going to label that in there real quick saying, hey, this is our short leg. We're going to draw another little map here. We like these maps. Okay, you may not, but I do. How can I change this from green to a different color? That's all. So, if I call my short leg X, how can I get to the hypotenuse? 2x. So what math do I do? I multiply by 2 to get to 2x. So how I get there, I multiply by 2. We're going to draw on this map here again, our little road maps. And how do I go back then? Divide by 2, right? I do the opposite, multiply to get there, divide to get back. And it would make sense, right, that we would multiply to get from a short leg to a hypotenuse, because the hypotenuse has to be longer, right? And typically speaking, when we multiply, do we get bigger or smaller? Typically, we get bigger as we multiply. So then to go back to my hypotenuse of short leg, we would divide to get smaller. Okay, questions on that? Okay, so down here, on triangles 1, 3, and 5. On triangles. On triangles 1, 2, 3, and 4. Or excuse me, 1, 2, 3, and 5. Let me misspeak again. Let me start that. On triangles 1, 2, 3, and 5, the fourth measures on them for side lengths. I want you to find either the short leg or the hypotenuse. So on 1, you already have hypotenuse. What would we find? On 2, we already have what? So we find hypotenuse. Okay. So on and so forth. So on 1, 2, 3, and 5, I want you guys to find either the short leg or the hypotenuse, whichever one we don't have. When you have all 4 of them, or have questions, raise your hand. You have all 4 of them, or have questions, raise your hand. What was that? Yep. We'll go back to that. Very good. You want to check? Yeah. You want to check? Oh. You want to check? Oh. Yeah.
So much cross on the weekend.
kind of firm. And then
Yours is colored.
we're actually just doing the color chocolate gray and green.
I like color.
Same.
So is it gonna be more? Okay. She's done it to
She said she missed that.
Oh, the numbers.
Well, eventually we'll do that.
Wait, so like what type of wedding are you gonna have? Like a barn wedding, like a big wedding,
So it's
church wedding, or?
in a venue called the Living Room. So we're having our ceremony in our church. We're having a reception. And it's like an industrial type building with like exposed brick and stuff like that. After you find those links, so actually we'll sit back down for a moment here. So what was the short leg on number 1, James Michael Stevens? 6. What was the hypotenuse on number 2 here, Rachel?
8.
8. What was the hypotenuse on number 3, Jocelyn?
I don't know what to do.
Okay. So what are we given? Short leg or hypotenuse on number 3? Okay. So how do we go from short leg to hypotenuse? What does it say? Okay. So what would we get?
What? Where'd you get the 5? Oh, okay.
10. Okay. Here you go. So on number 5 here, we have the hypotenuse is 100. Maggie, what's our short leg? 50. Very good. Okay.
Oops.
Now guys, on these 4, I want you guys to use the Pythagorean theorem to find our missing side length. I want you guys to use the Pythagorean theorem on these 4 to find our missing side length. I know.
I don't know how to do that, sir.
What if you know the
Let's walk through the first one together. In case you guys need it, let's walk through the first one together. So can somebody help me set this one up to find this missing length?
6x squared,
6 squared.
plus x squared equals 12 squared.
Okay, 6 squared plus x squared equals 12 squared. We need this x, our missing length, to be one of the legs, and 6 to be the other leg. 6 times 6 is 36, plus x squared equals 144. Subtract 36 and x squared equals 108. Square root. X equals the square root of 108. As we start to simplify, we look for square root of 36 times square root of 3. Square root of 36 is 6 times the square root of 3. Now I would want you guys to do 2, 3, and 5. So we did the Pythagorean theorem on number 1 to find the missing side. Or the same thing on 2, 3, and 5. Take a look. Gotcha. Hoping for the best.
Did you just apologize?
No.
Or they said no, sorry. And I was like,
Did you get the,
Almost.
Well, it's all discovery. Yeah, it's just
64 minus 16.
So we turn skip 7.
48.
I have to retake that. I think I might be able to get 2
So do your best way.
Ah! I found the pattern. Yep.
I still have an A, and then you go, then you find out like
What do you mean? What do I?
oh wait, and then I think you go.
Back to 48. What did you get back to?
Me about.
Oh my god.
I know number 2.
I'll do number 70.
Those 49,
Oh, I knew there.
49 plus 38. So 7%.
Carly, I love your shirt.
Bro, I can
Like, I don't know, doing all my things. Yeah. What? I don't know when I did that. Oh my God, that's weird.
Jocelyn, what's the I missing length on number 2?
I just think the whole thing. It's okay, my answer is like x equals 2 to the square root of 12.
Okay, we can simplify that even more. So if you have
Even
2,
more?
if you have 2 squared root of 12, what's the perfect square factor of 12?
I want like 4 and 3.
Yeah, so 2 squared root of
So it's
4
and 3.
times 2 squared root of 3. So what's square root of 4?
2.
2. So it's 4 square root of 3, right? Yeah, there you go. Number 3, what's my missing length? Anyone want to volunteer for that one? Okay, Kevin?
Are we just saying what answer we got?
Yep.
I got 5 square root of 3.
5 square root of 3. Number 5, is anyone want to tell me what my missing side length is? My other leg? Okay, Justin?
50 square root of
50 square root of 3. Anybody notice a pattern here?
3. No, the short leg to square root of 3.
Short leg times square root of 3. In all of these 4, it's just a short leg times square root of 3. Yeah. So let's go back up a little bit. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg. And the long leg is what we're going to call it. We're going to call it the long leg. If we have a short leg, we have a long leg. Is square root 3 times as long as the short leg. So for our map, to finish out this map, we're going to have the long leg. And if the short leg's x, what will our long leg be? 3x.
X to square root of 3.
X times square root of 3. X times square root of 3. So how do we go from our short leg to the long leg? Times by the square root of 3. Multiply by square root of 3. Then how would I go back, guys? I divide by the square root of 3. And I want us to write all this in here on the map. It's going to be helpful for us later. Like seriously, if I don't see it on the map, I'm going to be like stupid disappointed. Like, yo, go back and do that again. Okay, what? Yes. Okay. So, Kevin.
Did you say you're stupid disappointed or just stupid?
I would be disappointed. I would be stupid disappointed. Okay?
So just say hi to him in the future.
So, on number 4 and 6, we haven't done anything with those, have we? Okay? That's on purpose. So on 4, I'm going to give 8 times the square root of 3. And where did I put that length at?
Oh.
Long leg.
On the long leg, okay? And on number 6, I'm going to put on the long leg as well. The length is 7. Now keep in mind, to go back to above here, can you go from long leg straight to hypotenuse or hypotenuse straight to long leg? No, where do we have to go through? Short leg. Okay? So keep that in mind here, and I want you to find the other 2 side lengths on 4 and 6 without using the Pythagorean theorem at all. So I want you to find the other 2 side lengths on 4 and 6 without using the Pythagorean theorem at all. This is just normal 7.
Oh.
So it's going to change up that. No, I didn't.
Okay, yeah, I give up.
I got it.
So this is double short. Short leg is long leg. So, what did we do earlier?
I just file it down now.
Okay.
No, no, no.
Go.
It's not.
Kinda concerning that I go on it.
Oh, are we checking?
Yes. Yeah.
Oh.
You gave me that.
How do I go from
Like,
long
I'm
leg
checking.
to short leg? Long leg to short leg. This is across from
How?
How do I go from long leg, which is across from 60, to short leg across from 30? Long leg to short leg.
That's weird.
You're really cool to like sit in silence for so long that you're like, ah,
So what's
like,
clear to be
forgot what you said, like, sound like. Never forget what you sound like. Never sad. I mean, I know you talk to yourself, but like,
Yeah, like when I text it. Text out loud, I don't know why.
that's good.
on that leg.
It's so weird
Oh,
though.
that's weird.
I've read
Okay.
imagery.
On number 4, what are we given?
A question.
Are we given short leg, long leg, or hypotenuse?
Long leg.
Long leg. So from long leg, where can we go?
Divided by square root.
The short leg, how?
Divided by square root.
Square root of 3. So what's 8 square root of 3 divided by square root of 3? 8, because the square root of 3 is simplified. So it's 8. Now how do I go from short leg to hypotenuse?
Times 2.
Multiply by 2, double it, so I get
16.
16. Boom, that one's done.
Yeah, now number 6.
Number 16 is a little weird. How do I go from long leg to where? Short leg. How do I
Divided
go?
by square root.
Divided by square root of 3. 7 divided by square root of 3. Then we say, but wait, we don't want to divide by a radical. So what do we do now?
It's 7.
Multiply by 1, and we want to make it look like square root of 3 over square root of 3. Why do we choose square root of 3 here when before we chose square root of 2? Because we have square root of 3 already on the bottom.
7.
So now 7 square root of 3
over 3.
over normal 3 is our short leg. So 7 square root of 3 over 3 is our short leg. It's not clean, but it's the short leg. So now how do I go from short leg to hypotenuse? Multiply by 2. So what's 7 times 2?
14.
14 square root of 3 over 3 is my hypotenuse. Yes, Alyssa.
So the square root of 3 over the square root of 3 is the same value of the square root of 2 over the square root of 2, right? So would it make a difference if you didn't multiply by that?
Yes, because, so let's ask, hey, square root of 3 or square root of 3 is 1, and so is square root of 2 or square root of 2, so would it make a difference if we multiply by that? And the answer is yes, because if I took square root of 3, 7 over square root of 3, and multiply by square root of 2 over square root of 2, I get 7 square root of 2 over the square root of 6. Does that help me get rid of my radical? No. So that's the specific reason why we chose 3, was because it helps me get rid of my radical at the bottom. Yeah, great question. Okay. Any other questions on 4 and 6 here? Okay. We're gonna go ahead and actually skip the example 2 there and be done with our notes.
Oh, I didn't know.
Oh, cool.
Could you catch it?
Sure. One second.
Oh.
Nice looking pen. You're a much better drawer than I am. Maybe I'll just have you do this next time. No? Never mind.
Well, I don't ever think
Okay. Yes, I do want you to do all these. I mean,
I didn't mean to draw it off.
It smells like watermelon.
That's a bit weird, Justin.
Yeah, I don't know. You just leaned over and I smelled some crap. Like fresh white water.
Well, I didn't brush my teeth this morning, but I did put on some lip check. So I didn't.
Kevin!
I was in a hurry. I have gum though.
I brushed my teeth like this literally 3 times today.
I brushed it last night
everything's good.
I brushed one of you.
before I went to bed shortly.
I brushed before I
And you
go to bed.
call this one I do. I brush mine
You
for a
have
little
nasty
few
rhymes
minutes,
for
and then I
like
rub my tongue,
stuff.
and then
Like
rinse
so-
my
Hey,
mouth
real
with
quick,
sauce,
I think this might help it stick a little more, guys.
and then rinse my mouth with sauce.
Okay, 1 second. Hey, I think this might help it stick a little bit, guys. On the 30, 60, 90 triangle, one thing I noticed is a lot of people get it confused as to which one we multiply by 2 and which one we multiply by square root of 3. Okay? So how we can remember is which one has to be longer, the long leg or the hypotenuse? Hypotenuse. So we're going to multiply by a bigger number or a smaller number to get to the bigger side. Bigger number. So between 2 and square root of 3, which one's bigger? Well, 2 is the square root of what number? 4. So which one's bigger, square root of 4 or square root of 3? Square root of 4. So we're going to multiply by 2 to get the hypotenuse because it's bigger than square root of 3, just the long way. Okay? So that might be something that might be able to help some confusion for you. Okay? And that's actually all I have for you.
Yeah.
I lost
Yes,
the cat.
the mean. No, I don't like 7.3, so I skipped it.
Oh.